Hi students, so today we will continue talking about domain and range, but as they relate to word problems. So this is the next step, being able to read a word problem and just from the story be able to determine what is the domain, what are my inputs, and what is my range, what are my outputs. So the essential question is, how can I determine the domain and range from a real world problem? This is what you need to be able to answer by the time we're done with this lesson. So we're going to start off by reviewing some vocabulary in a big old T-chart. We've got X on the left and Y on the right. Just in case you can't see those, I'm going to highlight them. Alright, so we want to remember what words are associated with X and what words are associated with Y. X, that is our independent variable, which means it helps determine the Y, or the output, because the Y is the dependent variable. It depends on the X. So the X determines the Y. The Y is nothing without the X. So we're going to look a lot at the X as the domain to help determine the range. And we'll do that in a minute here. X, remember, all the X values together are called the domain, and all the Y values together are called the range. So we're going to be determining both of those. We can also think of our X's, or our independent variable, or our domain as our inputs. And our inputs are what we put in, and then out pops an output. So that is the Y's are the result. Alright, let's take a look at some examples. So in these word problems, you're going to have some scenarios, and a lot of times you'll have to determine what are the quantities. Once you determine what the quantities are, you have to figure out, well, if I was to graph these quantities, would it make a graph that is discrete, or would it make a graph that is continuous? So just to remember what that means, discrete graphs are like individual dots, like a scatter plot. Okay, continuous graphs, you would want to connect all the dots to make some kind of line or curve. So kind of think about that. The thing that we want to look for, here's the key. We want to look at the domain or the input. Because remember, the domain or the input determines the output. So if we can look at that domain or input, we can see what kind of numbers we're going to have, and that'll help us to determine the kind of numbers that will output, which will ultimately help us to determine whether our data should be connected with a line or should be separate. So here are some examples. Buying candy bars at a store. So for all these examples, we're trying to determine, are they discrete or are they continuous? If I'm buying candy at a store, think about what you're going to be doing. You're going to bring candy bars up to the register. They're going to figure out how much it costs, and then you pay. So to me, it's like the number of candy bars is going to determine the cost. So number of candy bars, that would be my input. And that helps determine the cost, which is my output. So you want to think about your inputs. Okay, because remember I said the key here is think about your inputs. Number of candy bars. How many candy bars could you buy? You could buy 1, 2, 3, 4, and so on. You can't buy a part of a candy bar. So if I was to graph numbers of candy bars against cost, I would go from 1 candy bar, put a dot wherever that cost is, and then I would jump to 2 candy bars, put a dot. I would not connect those because I can't buy parts of a candy bar. So this would be an example of discrete, and I'm going to put a big D for discrete. This is discrete data, so this data would look like dots. All right, let's look at the next one. Renting a movie from the store. Now, I know we don't do this anymore, but a long time ago, you used to go to a store, find a movie you wanted, and you would rent it. Just like the candy bars, the number of movies you rented is going to determine the cost. So the number of movies, again, would be my input. And of course the cost can be anything, and it's determined by the number of movies. Well, once again, number of movies is kind of like candy bars. I could rent 1 movie, 2 movies, 3 movies, but what I can't do is rent part of a movie. So once again, we're going to jump from, an input of 1 all the way to an input of 2. There's going to be no inputs between 1 and 2, no 1.5s, no 1.75s. So we would not want to connect these dots either. So this graph would also look discrete, just dots, like a scatter plot. All right, the next one, buying candy by the pound at the store. So this is a little bit different. Lots of places don't do this anymore. But you can also think about buying like fruit in the produce section. So whenever you buy candy by the pound or fruit by the pound, you put it on the scale. The scale, can read any weight, and then that gets multiplied by the price per pound. So once again, the input is the number of pounds. Pounds is abbreviated with LBS. That's your input. But you don't have to buy exactly 1 pound or exactly 2 pounds. They will just take that decimal point or that part of a pound and multiply that with the cost per pound. So it'll be included. So this would be an example of where you could connect to the points. So this graph could be continuous. All right, and then the last one, the timing the football players in doing bear crawls. So your coach would probably tell you how many bear crawls to do and then time that, right? So I'm thinking, and I'm not a big sports person, but I'm thinking the input would be the number of bear crawls, and then that would determine how much time it took. Excuse me. So the input would be number of bear crawls. I'm not sure if a coach would say, hey, do, 2.33 bear crawls. They would probably round it to the nearest whole number, right? 2 bear crawls, 10 bear crawls, 20 bear crawls. So I don't think it would make sense to include decimals or fractions between those whole numbers, which means I wouldn't connect the points, so I wouldn't have a continuous graph, so I would once again have a discrete graph. So this is really important to be able to determine if your graph is discrete or continuous, because from there, like we learned last time, you will represent your domain and range differently depending on if you have discrete or continuous. Just to remind you, when you have discrete data, you are going to list your domains and ranges so that you'll just separate them with commas. When you have continuous data, you're going to use the inequalities. So those are like your less than, greater than, less than, equal, greater than, equal to. Okay, so just remember the differences. Now let's see some actual word problems. So here's example 2. Michael rents movies from a mail order movie rental company. So after we had these video stores, Netflix, for example, before you could stream it, you would rent a movie online and they would actually mail you the disc, the DVD, and then you would have to return it. So this could be an example like that. So to continue, it says for each movie rented, it's $2 and a one-time $10 member's fee. How much has Michael spent if he rented 20 movies? So first we need to figure out what's our input and what's our output. So usually when you're talking about money, the amount of something that you're buying or spending or selling determines the cost of that item or the price you have to pay or whatever. So usually money is an output. So for our input might be the number of movies, and then the output would be the money, okay, or the price of the movies. Okay, so let's go ahead and make an XY chart and just kind of look at the data a little bit. Okay, so remember that X is the number of movies, that's our input, right? And our output is the cost. Okay, so for example, let's say he orders one movie or he rents one movie. It's going to cost him $2 plus he has to pay a one-time $10 fee. So it's going to equal $12 if he buys one movie. Okay, so there's one input-output pair. When my input's 1, my output's 12. Okay, let's think about if he rented 2 movies. Okay, well it's $2 per movie. So that's going to be 2 times 2, plus he still has to pay the $10 member's fee, that one-time fee. So that's going to be 2 times 2 is 4 plus 10 is $14. Okay? Or he could rent 3 movies. So $2 times 3 movies each, that's $6 plus the $10 fee. Now he's up to $16. And then you can start to see a pattern develop, right? Well, he could rent... It says he talks about him renting 20 movies. So we could do this pattern all the way to 20, right? And now that I see the pattern, I can just continue it. It's 2 times whatever X is, in this case, number of movies, 20 movies, so that's $40, plus that $10 membership fee. So that's going to be $50 to rent 20 movies. But we also are looking at the domain and range. So first of all, just like in the previous example, because you can't rent part of a movie, there wouldn't really be a need to connect these input-output pairs. So let's take a look at our graph and see what would the graph look like. I want my graph to go from, so the X values are here, Y values here, Y values are our money, X values are our movies. I'll just kind of abbreviate that. All right, so we want to go from 0. Let's maybe for the input, since we're going 1 to 20, maybe we count by 2s. So 2, 4, 6, 8, 10, 12, 14, 16, 18, and 20. And then for our cost, we're going from 0 to, it looks like 50 is our largest cost. So maybe we count by 5s on the y-axis. 5, 10, 15, 20, 25, 30. And if you're taking these notes by hand, you could just sketch this graph. You can use some of the graph paper if you want that was given to you with your backpack. Either one is fine. All right, so let's go ahead and plot some of these points. So what would it look like? Let me make this a little bit bigger. Okay. So our first point is 1, 12. So 1 is our X value. We're going to go up to 12, so that's kind of right there. The next point is 2 movies cost $14, so we'll go to 2 movies. 14 is about right there. 3 movies cost $16, so that's about right there. And I can kind of see that it's going up from left to right. If this was a scatter plot, it'd be a positive correlation. Our last point is 20 movies cost $50. So if I was to fill this in, right, there would be a bunch of points between those points. So I can just kind of like imagine what that would look like. It would be some points in here, right? And that's not exactly. But I wouldn't want to connect the points because there's no way I could rent part of a movie for part of the price. So this would be an example of discrete. This would be a discrete graph, and that's going to influence how we write our domain and range. Okay, so for our domain, remember we want to do the curly brackets. Because it's discrete, we're going to list the numbers. The first input value is 1. We can have 1 movie, comma. We could have 2 movies, comma, 3 movies, comma. And I could keep going. Now that I see a pattern, I can put dot, dot, dot to the end. 20 is my largest domain. So these are all the possible inputs. I can have anywhere between 1 and 20 inputs. Okay. Our range, these are outputs. These are the possible prices. The smallest price it's going to cost if I rent 1 movie is $12. If I rent 2 movies, $14. 3 movies, $16. Dot, 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 20 movies, $50. So notice that both the domain and the range go from least to greatest, and they are listed separated by commas because it is discrete. So this is an example of discrete word problem. And here's our last example. Your parents finally decided to fill the kiddie pool swimming pool for the summer. The pool can hold 32 gallons of water. The water hose runs at a rate of 2 gallons per minute. How many minutes does it take to fill the pool? So remember, with any of these types of problems, there are two variables or two quantities you're looking for. A key here, when you're looking, is look at the units. I see 32 gallons. I see 2 gallons per minute. So I'm thinking gallons and minutes might be my two variable quantities. So let's think. What's going to influence what? I'm filling a kiddie pool. It starts off empty, right? Is the number of gallons I put in the pool going to determine how long it takes, how many minutes it takes to fill it? Or is the number of minutes it takes to fill it going to determine how many gallons I put in? So to me, it makes most sense that the amount of water I put in and the rate that it's flowing is going to determine how long it takes to fill up the pool. So I'm thinking that the input value, my x value, should be the number of gallons, and my y value should be the number of minutes it takes. All right, so let's think about it. If we put 0 gallons in the pool, it's going to take 0 minutes to fill that up, right? And then what's the next number of gallons we can fill the pool with? Would we just dump in 1 whole gallon? No, it says the water hose runs. Well, the water hose is slowly filling up, right? So over time, this number is increasing, right? Let's say it goes all the way to 1, okay? If I fill it with 1 gallon, so it's going to take 2 gallons per minute. So that's going to be, you know what? Now that I'm thinking about this, this might work better to do it another way. I'm going to erase this really quick. So sometimes you can kind of fool yourself into thinking it one way or another. So I'm going to think about this a different way. I'm thinking when I fill up a kiddie pool, I don't really know how many gallons I'm putting in at a time, right? I just run the hose for an amount of time and then until it's full, right? So to me, I kind of want to switch my input-output. I think it might work better or make more sense if my input was the number of minutes we run the hose, and then that determines how many gallons get filled. So I'm going to flip these. To me, it makes a little bit more sense. So let's start over again. 0 minutes running the hose, 0 gallons in the kiddie pool. All right, so some time passes. Let's say after a minute, it says it fills 2 gallons per minute. So I know after 1 minute, 1 minute times 2 gallons, I have filled up 2 gallons. Okay, let's say, another minute goes by. Now we're to 2 minutes. Okay, well, it's 2 gallons per minute, so 2 gallons times 2 minutes equals 4 gallons. So I can kind of see a pattern. For every minute I fill it, 2 gallons get added. Perfect. So I want to go all the way to 32 gallons when my output is 32. So I got to think, okay, well, how many minutes would that take? If it's 2 gallons per minute and the pool can hold 32 gallons, that means it took me 16 minutes, right? 16 times 2. Let me erase this a little bit. 16 times 2 is that how we got the 32. Okay, and then I could have lots more data in here, right? But I kind of see my, kind of like my starting numbers and my ending numbers. So that's kind of what you want to look for when you're doing your domain and range. So let's take a look at our graph. I've got X and Y. Remember, X is my minutes, Y is my number of gallons. So, here are my ordered pairs, 0, 0, 1, 2, 2, 4, 16, 32. So let's go ahead and graph these. Okay, So before we do that, though, we need to we need to number our axes, right? Our scale. So minutes need to go from 0 to 16. So I've got 0 here. Maybe we count by 2s. So 2, 4, 6, 8, 10, 12, 14, and 16. And then our y's need to go from 0 to 32, so maybe we count by 4s. 4, 8, 12, 16, 20, 24, 28, up to my 32. Those numbers are really little. All right, let's go ahead and start plotting these. So our first point is 0, 0. Boom. Actually, let me make that a little bit bigger. Boom, 0, 0. Next point is 1, 2. Actually, let me redo that last point. Make it more the origin. The next point is 1, 2, so that's kind of like right there. The next point is 2, 4. My last point is 16, 32. Now, we have to decide would it make sense to connect these points or not. Well, it's not like we run the hose and then we wait a minute, we turn it off and wait a minute and then run it. The water is continuously flowing, right, this whole time, which means I really want to connect these dots. I want this to be a line or a curve, okay? And if that's the case, that means we don't have discrete data, we actually have continuous data. So this data is continuous, and remember, that's going to affect the way we write our domain and range. Oop, can't spell continuous. There we go. All right, so for our domain, if it's continuous, we're going to write an inequality. So we're going to go from least to greatest, and we're going to be looking at our x values, least to greatest on the x values. So we're going from 0 to 16. So our smallest x value is 0. I don't have any open dots on my graph, so they're all closed. So I'm going to always put a less than or equal. The variable for domain is x. Put another less than or equal, and then the greatest value is 16. There's my domain. Now for my range, remember we're looking at the y values from lowest to highest, least to greatest. So the lowest y value down at the bottom is 0. Again, we're going to put our less than or equal to. This time we're going to put y because that's our range. Put another less than or equal. The reason why they're all less than or equals is because we don't have any open dots. And then our largest y value is that 32 gallons. Okay, so there's your domain and range. Now these type of problems take some practice. Some of the problems on the star, they might just say, what's the range? Well, here's the deal with range. You can't find the range until you know the domain, because domain's the input. So the range problems always take a little bit more time. The domain problems are pretty easier, or a little bit easier to figure out, because you're just trying to figure out what are my inputs. But remember, with the range, you got to find the inputs, put them in, and then figure out what your range is. All right, guys. Hope this was good. I know you probably have some questions, but we'll talk about them in class.